Hello everyone, let's solve the problem number 54, spiral matrix. So what the question states here, we are given m into n 2D matrix. So you can clearly see here, we are given an m into n matrix. So we have to return all the elements in the spiral order. So they have asked us to return all the elements in the spiral order, starting from the top left and moving clockwise inwards. So you can clearly see. Let's come to the first example here. Starting from the clockwise means here this one. Starting from the top left. Sorry, top left is this one, right? 0, 0. This one. So this one we have to and moving clockwise inwards means first this one, right? Starting from the top left, this one, right? Then they have clearly showed in the figure. So 1, 2, 3, 6, 9, then 8, then 7, then this one 4, then finally completely the middle element, fifth one, right? Middle for this particular example. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9 we have. This will be 1, 2, 3, 6, 9, 8, 7, 4 and 5. So that's what we need to return as output. So let's come to the second example here. So here in this case, we have just give me a second here. 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11, 12 we have. For 1, 2, 3, 4, we'll move with 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, then middle 6 and 7. So this one we need to return this one as output, right? So I hope the question is completely clear. What we need to do is completely clear as well. We just have to move in the spiral order. All the elements, we have to return all the elements in the spiral order, basically starting from the top left and moving the clockwise inwards. That's what they have given. Simple to understand, right? Let's discuss the approach first, followed by edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach first. So here the first thing that we need to note down here is we will be going with the layer by layer traversal. So just keep this in mind. We'll be going with the layer by layer traversal approach. So the first thing I have considered the same first example that they have given in the question here. Matrix equals 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the spiral order, we have to get the output 1, 2, 3, 6, 9, 8, 7, 4, 5. We have already discussed this one, right? So let's go with the step-by-step execution. Let's discuss the step-by-step execution here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. This one, right? So let's move with the first step here. We will traverse the so basically we are going with layer by layer traversal, right? So first thing what we will do, let's discuss the spiral steps here. We will traverse the top row. When I say top row, this one 1, 2, 3 I am speaking of, right? So we will be traversing through the first row. So this one 1, 2 and 3. After traversing the first row, what we will do, we will traverse the right column 6, 9. So top row, then right column. Top row, then right column means this one 6, 9. Now we have 1, 2, 3, 6, 9, right? So then we will traverse the bottom row. When I say we will traverse the bottom row, this one 8 and 7. We have now 9, 8, 7. This one, right? 8, 7. So we will traverse the left column. This one, left column. We already have one, so we will ignore this one. So finally, the final step is we will continue with the inner matrix, nothing but 5 in this case, right? We will continue with the inner matrix. In this case, it is 5. So this one here in this case. Now we have to get the output 1, 2, 3, 4, 5. 1, 2, 3, 6, 9, 8, then 7, 4, 5. So this is the output, right? Step by step. The spiral, this one. Spiral steps we saw. We traverse the first row, then right column, then bottom row, then left column, and then the inner matrix. Top row, right column, bottom row, left column, then the inner matrix. This is fine. So the final result that we got here is 1, 2, 3, 6, 9, 8, 7, 4, 5. Here I wrote the same thing right here. 1, 2, 3, 6, 9, 8, 7, 4, 5. So which is equivalent to the output that they have given for the first question. So the output that we got here is 1, 2, 3, 6, 9, 8, 7, 4, 5, which is equivalent to the output that they have given for the first question. Here see, first example in the question 1, 2, 3, 6, 9, 8, 7, 4, 5. So the approach works absolutely correct in this case. Absolutely correct, right? So what we'll do now, as we are completely familiar with the approach, let's do one thing. Let's discuss the edge cases one by one, right? So I'll Just give me a second here. So the first edge case is for the single element matrix. So when I say single element matrix here, we have only one element in the matrix, so we have to return that itself. So in this case the output is 1, right? So let's move on with the second edge case here, single row matrix. So we have the elements 1 2 3 4 here, right? So we have the elements 1 2 3 4. This is a single row matrix, so we will return the same. In this case we will return 1 2 3 4, right? So let's move on with the third edge case here, single column matrix. So let's move on with the third edge case here, single column matrix. When I say single column matrix, we have the elements 1, 2, 3 and 4 here, right? So the output that we need to return here is 1, 2, 3, 4 itself, right? Because it is single column matrix. So single row, it goes with same. Whatever the elements that is present in the row will return the same. Same goes with the single column matrix as well. Whatever the elements that is present in the column will return the same when it is single column matrix. Then the final one here is even sized square matrix. For the even sized square matrix will return the same again. 1, 2 and 3 and 4 we have here. In this case we will return 1, 2, 4, 3. So we have 1, 2, 3, 4, right? First we will go this way, 1, 2, then 4, then 3. This will be 1, 2, 4, 3, right? So we'll return the output 1, 2, 4, 3. So these are the 4 edge cases that we need to keep in mind here. So the first edge case is for the single element matrix, the second case edge case is for the single row matrix, the third edge case is for the single column matrix, and the fourth and the final edge case is for the even sized square matrix, right? So now we are completely familiar with all the edge cases as well as the approach. As we are completely familiar with the edge cases and approach, now we are good to write the code. Let's start writing the code. So the first step that we'll be going with here is we have to go with the result list to store spiral characters. We'll be making use of the array list, right? So I'll just go with the list, nothing but the result list here. So I'll just go with the list, which consists of the type integer, and I'll go with the variable name here, result, res. I'll just go with, let's create the new array list here. I'll just give new array list. This is fine. So the first step is we are going with the result list to store the spiral elements. We have to store the result somewhere, so we'll be making use of the result list. So nothing but we have successfully created the array list. Then now we have to go with the top and bottom boundaries, also left and right boundaries, right? Let's initialize top, bottom, left and right boundaries. So for the top and bottom, I'll just go with int top equals 0. For the bottom, I'll just go with bottom equals the last one. I'll just go with length of the matrix. So this one, let me give here length of the matrix minus 1. In this case, next we have to go with the left and right boundaries. When I say left and right boundaries, I'll just go with int left equals 0, right equals matrix of 0. This is for the left and right, right? So I'll just go with matrix of 0 dot length minus 1. This is fine. Easy to understand. So after going with the top and top, bottom, left and right boundaries, so we have to iterate while we have the layers. While we have layers only, then we can iterate. So we'll be making use of the while loop here. So I'll just go with while top less than or equal to bottom here in this case, and left less than or equal to right in this case. What we will do in this case, so we will iterate while we have layers. So what we'll do, we will move from left to right on the top row. So I'll just make use of the for loop here, int, so j equals here in this case it is left j greater than or equal to right, and let's increment the j here. This is fine. So first we are iterating while we have layers, and we are going with the left to right on the top row. So in this case, we have to move top down, right? First left to right, then we have to move top down. So first let's add this one to the result. I'll just go with the add property. I'll just make use of add property here. So let's go with the matrix of top of j, this one. So did I miss anything? Do anything wrong here? Matrix of top, this has to be, just give me a second here. So yeah, this top is different basically. This j is different. So I got confused here. This is fine. Then let's move top down. Once let's increment the top here. This is fine. The next step here is we are going with the top to bottom, right? We are going with the top to bottom. First we went with left to right. As per the approach, we have to move in the spiral order. We have to go left to right. We'll start from the top left, right? So left to right we went. We already wrote the code for the left to right. So next I'll just copy the same thing and make the necessary changes. Next we have to go from top to bottom. So here let me show this one once again here. First we went left to right. Now we are going top to bottom. For that one we have to write the code. Next, after top to bottom we have to go from this one here. We have to go left and then finally left column and then finally inwards, right? So let's write the code for the same. So here this will be instead of j it will be I equals top basically. Instead of left this will be top and I less than or equal to bottom here. In this case I less than or equal to, this will be bottom. So I should have typed instead of copying this one. This is fine. Then we have to add that one to the matrix, right? So I'll just go with here matrix of, this will be I right. This is fine. So this here in this case we have to move right boundary inward. So let's decrement the right. So I'll just go with decrementing the right. This is fine. So this is it for top to bottom on the right column, right? So the next step is we have to check bottom row, the last row still exists or not. This one I'm speaking of. So just give me a second here. This one I'm speaking of. This still exists or not. This the bottom row, right? So this still exists or not, we have to check for. So I'll just write the code. Let's write the code for that. If simple if condition here, top less than or equal to bottom, then what we will do, let's write the simple for loop here for int j equals right, and then j greater than or equal to left, and let's decrement the j here. This is fine. So let's make use of the add property here, result.add. Let's add this one matrix of this one. What we are adding, bottom row, the elements that are present in the bottom row. We are just going step by step, left to right, top down, bottom. Next we will go with the left column, right? So here this will be bottom j. After adding we have to move the bottom boundary up, means the left column we have to move. So I'll just give here bottom minus minus. This is fine. So the next step here is we have to check only the left column. So now where we have stopped, just give me a second here. First we did this one. This is fine, left to right. This one is completed. This one is also completed. Now we have to check for the left column, right? So now we have to check the left column still exists or not, right? So I can copy the same thing, this thing from line number 17 to line number 20 and do the necessary changes, but let's write the code. Let's type instead. Sorry. So here, so this is fine. So let's move on with the next step here. If left less than or equal to right, so what we will do, we are checking whether the left column still exists or not. For for loop, what we will do, within this we have to write the for loop, means we have to move from bottom to top on the left column. So I'll just write here int I equals this one will be bottom. We are moving bottom to top, right? So here on this, in this case it will be I greater than or equal to top, then let's decrement the I here. This is fine. Then we have, let's add that one to the matrix. So I'll just make use of the add property. We are adding to the result list, right? So I'll just give here matrix of I left, nothing but the left column, right? We are considering the left column, we know this one. So successfully now we have successfully written the code for the left column. So now we have to move left boundary right? So inwards, this one is left. I'm speaking of this one. Now we have come here. So this one we did, this one we did, this one we did, this one we did. Now we have what we need to do. We have to move left boundary, right? This one towards the middle, right? So that's what. So I'll just give me a second here. I'll just come here. So let me increment the left. So this is it. Finally, we have written the code successfully. Finally, we have to return the result list. We have to return all the elements that we have to show all the elements, right? For that purpose, we have to return the result list. I'll just give here return result. So let me format the code once. We have written the code step by step here. This is it for the code. Let me hit the run button. I hope this works. Let's see. So here we have some error. What is the error we have basically? Array bounds of exception. Let's check here itself. Wait. Matrix of the first one. So here we are checking for this one, right? We are iterating while we have layers basically. While this is fine. Well, top less than or equal to bottom and left less than or equal to right. What we are doing here for int j equals step. This is fine. J less than or equal to this has to be less than or equal to right, not greater than or equal to right? So this j has to be, we are checking whether j equals left, j less than or equal to right, and then we are incrementing the j. So let me hit the run button. So now this has to work. Let's see. So yeah, you can clearly see here the sample test cases are getting passed. Means the code works absolutely correct in this case. Let's see whether this works for all the test cases. Let me hit the submit button. So you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So here in this case, the approach that we went with here is layer by layer traversal. We have already discussed this one multiple times. So, so the approach that we went with here is layer by layer traversal, nothing but simulation, right? So in this case here, what would be the time complexity? Overall time complexity. So overall time complexity would be big of m into n. So overall time complexity would be big of m into n because we are visiting each cell exactly once in the spiral traversal, starting from the top left, right? We know this one. We are visiting each cell exactly once in the spiral traversal. So the overall time complexity would be big of m into n. So what would be the overall space complexity here? The overall space complexity would be big of 1. We know this one. We are not making use of any extra space apart from the output list. When I say output list, I'm speaking of this list, result list, right? We are not making use of any extra space apart from the output list, which is quite obviously required. The variables that we are making use of here is top, bottom, left, and right, which basically takes the constant space itself, right? So overall space complexity would be quite obviously big of 1, right? So the time complexity and the space complexity for the code that we have written is big of m into n and big of 1. So I hope the complexities are completely clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.